me go to the introduction slide. So I'm Yuki. I joined Sony in 2004, so I already been in this R&D field for more than 20 years. I'm actually overseeing three teams in three different continents: Japan, Europe, and US. And I'm now based in US, New York, because it's really close to our Sony Music office. I'm now serving as a visiting research professor at New York University. And also, I'd like to highlight, the past work, one of the past works, which is about sound separation. Very briefly, I know that, I don't have much time. So I believe we are the kind of the first one who used deep learning for music applications back in 2012. And after that, we integrated deep learning in the sound separation technology. And we joined international competitions during this period, 2015 to 21, and we achieved, the first places. And now we quit from the competition, but instead we started organizing international challenges. The first one in 2021 was called Music Demixing Challenge, and now it's extended to include cinematic separation, and it's called Sound Demixing Challenge. I'm gonna also host, new challenges in future. And now I wanna show one example we've done with Sony Music, which is the new remixing version of the performance of Glenn Gould, the Canadian pianist. So what we did is actually we have extracted the piano performance of Glenn Gould in the old recordings, and then the artist here, on the right hand side, the Japanese famous actor, his voice was recorded on top of the extracted piano performance. So I'm gonna play back. I hope it works. So the first sample you hear is the original piano with the original dialogue.
Annie Lee, the prettiest little damsel in the port.
So this is the extracted piano.
Annie Lee, 港切手の器量よし、小さな乙女。
So yeah, this was done in 2021, and the quality is not as good as the one we have, now. But yeah, it's still it is in the market. So and now it runs in real time, so it's in our latest noise cancelling headphone. If you have one from Sony, yeah, the separation technology is there. Yeah. So today's agenda, I need time management. So it's twofold. One is about the creation tool, and another part is, I believe it's more important in the music industry, the protection side of things. So let me start from creation. So I don't think this is needed for you to see here. So the creatives is actually the one part of music, the whole music business. So I'm gonna talk about the creative side, especially the music creation side. And there are many tools already out there that creators are using. Yeah. But actually, the one I'm gonna introduce is the waveform-based music generation and editing. And here, we're not the company who wants to have the fully automated music generation, so we are not doing that. But instead, we develop STEM generation and editing. So I think this is a great tool for creators. So this one is the fully automated diffusion work done by Queen Mary University of London. It was in 2003. I believe the most companies are following this, the training pipeline. So yeah, I'm not gonna talk about this, but just want to briefly touch upon. And the follow-up work doing the STEM generation, and this one actually can do total fully automated generation, but also this has a capability to generate STEM sounds given the human-made stems. So this is very unique, and this one doesn't have the capability to add reference audio or some reference context or text guidance. So our team actually developed something that can do that. So it should be around. It's hard for me to click. Oh, I don't know why. Doesn't work. Let me do here. Just want to jump to 33. Now, go. So if you have that kind of sound already created by creators, and then you want to add these drum samples to the mix, to the context, then the algorithm can automatically combine everything together. So this is made by human, and this is context. And the generated audio, given the reference sample, the guitar sample, then you can get this. So the model is. I need to stop now. And then there is also a very interesting line of works called music editing. So sometimes whatever you could get from the generative model, if you don't like, then you need to go back to the text prompt and you need to generate something. But it often is different from what you could get. Right, from the those two samples are too different. So the work called Music Magas can actually bridge the gap. So if you only want to change the instrument type, where is so this is the original. And please remember the melody. Okay. And also we are doing this automatic evaluation work studies. So since it's quite hard nowadays to evaluate all the output from outputs from generative models because they can generate as many samples as they like. So we are looking for the ways to automatically evaluate the quality of the generated sound, and we came up with the better evaluation metric called MAD, better than the previous conventional one called FAD. And we actually checked whether this MAD correlates well with human preferences, and then yes, the answer was yes. But we thought that, together with Carnegie Mellon University, we thought that we need more human preferences on the output of generative models. So we created, this is actually a sneak peek of called Music Arena. So if you go to the space, and then you can type a prompt, and then you can get two different versions of the output of generative models. So let's say one is refusion, one is other type of generative models, and then you can compare those two and then rate which one you feel it's better. Then here we can get many feedback from people, so that this can actually great ingredients to improve the tools that I presented earlier, like music editing, music stem-based generation, etc. So the last thing in the creation part I want to introduce is the music foundation model. So foundation model, the word itself was developed by Stanford, and what it does is, the definition of music foundation model. I mean, the foundation model is we need a model trained on a large scale data, and also the model should have the capability to be used for many downstream tasks. So GPT is one example in language space, and the ChatGPT is the actual the chat application of GPT, right? So music foundation model, once we could train this large model, then this can actually offer many music applications. Why we want to do this is because there are many ethical or legal issues out there about the training materials, and we as a Sony also care about that part. So we want to integrate, we want to gather all the data, and we want to manage everything at one place rather than spreading all data to many places and deal with many stuffs. So the applications we can see as the downstream task of a music foundation model could range from music heritage protection to entertainment industries. And also the interesting part of this is music heritage protection is very important in the how can I say, the underrepresented region, like in Africa, certain instruments are there, but once one music model could be dominant, then if that doesn't include the sound from the African minor instruments, then it goes wrong direction. So, and the music understanding is actually a very big topic for music foundation model. Music understanding means given the music samples, then the model can tell you about the music, or the reasoning is also another good application for this. The reasoning part can tell you why this music sounds similar to this, because this both are based on this, the classical some genre or something, and this can actually automate tagging or captioning process often needed in the music industry. So this is very interesting. And another one we recently published is about music foundation model for creative tasks. Actually, the one I showed you, the sound separation example, could be also boosted by the use of the feature from music foundation model. And I need to go really quick. So the next one is about the sound video to sound synthesis, and the model called Audio is actually from our team. And what we wanted to achieve is that if once the video creators create the video which doesn't have any sound, our system can add sound on that. So all the sounds you hear was fully generated given the video. So I'm gonna skip this and the protection part. So I enjoyed a lot the first talk from Aurelian from Deezer about the nowadays we see 80% of the music in the market might be from generative models, and I think it's inevitable to see this kind of the graph in 2030 because the tool can generate many samples. But the important part for music industry, I believe, is that data attribution is currently missing. So there's no way to get creators remunerated from of their songs used in the training data set of the generative models. So what is attribution? The technology is this is a rough sketch. So what input of the attribution model is the output, obviously the output of the generative model, and also the training data set you might have. And then this algorithm can compute, how much the one sample contributed to the generated output. And with this, the creators who created the red, the highlighted waveform can get money more than others, right? Then this is really the nice way. And yes, if this is about the, I call it first generation text-to music. Now we can do this because it's simple. I believe all the training samples are human-made, right? But if one day the training material could be also the output of some generative models, then it can go multiple iterations. Then how we can track this, right, the attribution? This is quite difficult. And now the phenomenon called model collapse, this was proved in the image domain. Actually, using synthetic data only for the training actually deteriorates the quality of the generative model. So you cannot do this right now because the service, if the quality of the service goes down. But I believe it would be 2 or 3 years to overcome this problem. We don't want to overcome this, but I know that someone will do this instead of us. So if this comes, then how we can solve the attribution problem? And this is actually still under discussion. We all want to find out the best solution to kind of avoid this nightmare. But still, I believe there's no solution. And another very important part of protection is memorization. This is also the phenomenon specific to diffusion model training. So I would say that all the diffusion models have this problem. So if you see any diffusion models trained on music data, this has this problem. This has a capability to produce exactly the same sample that was used in the training. And there's a way to get that, but also the way to avoid to generate that. And I skipped this. So this study was from us, done with New York University, and presented at Nashville CVPR25. We haven't done this in music domain, but we will. But anyway, this can actually provide a solution to avoid this memorization problem. Actually, no one can protect, companies from training on training diffusion on data, right? Music data, but there's a way at the inference time to avoid the memorization. And how we do this is, there's a transition point, and this point is, if you know the mechanism of how you feed text prompts to the system. People often use classifier-free guidance mechanism, and I don't think you need to know the detail, but there's a way to feed your text prompt to the system. And up to this point, transition point, you should not do that. You should let the model generate anything random. And then after this point, so diffusion is iterative steps. So you need to wait at this transition point, and after that you apply the text prompt guidance, and then you can get what you desire. So here you see the top image, actually the total copy of the training data set, and you don't want to get that, right? So to avoid that, you can also don't use any text prompt, but you will get something not desired, like the one at the bottom. And the one in the middle is actually reflects your text prompt and also can avoid the memorization. And I also want to introduce this activity with UPF in Spain. What we did is to we developed this music replication assessment tool that can quantify the difference between two songs. So with this, you don't need to listen to examples and say that, okay, this song is pretty similar to what I have, because this is subjective. So if you feel that they are similar, but some people say, okay, those are not similar. But if this tool could be there to say that, from a different perspective, okay, they are similar in terms of this, like a melody, similar, rhythms are similar, or total atmosphere are similar, or the singing, the timbre, voice are similar. Then, okay, there's no, way to excuse, right? Because the tool is saying that. So we have developed the first version, and we're looking for the next one to come. And this is about the exact. There are many ways of similarity definitions, but the easiest one is exact duplicate. So if the exact duplicate is embedded in between some different samples, then you can detect, like Shazam is the one specific application to do that. But what we are interested in now is near duplicate. So some part of the song are similar, right? So to achieve this, we need more clever algorithms, and the algorithm we developed in this spring can actually do this really in a robust way. So I'm not gonna go deep dive in this, but I just want to tell you. And we have a demo page, demo introduction page. Please check out this QR code and see our recent activities, especially around the protection side of things. There are many unknown things out there, and we're together with universities, we are looking for ways to overcome the limitations to build a great society in the era of Gen AI. So that's it from my side. Thanks for listening.
Yeah, thank you so much, 𝘬𝘂𝗶. Big round of applause, please. Amazing. I don't think we've got Steve here for the next panel, so thank you for sharing all of those insights and the knowledge, and for opening up our minds to see what's really going on and all the work that is happening and the brilliant stuff that you're doing. So thank you, genuinely.
Thank you.
And we have time for questions. Steve's just rocked up, but you okay to wait for a couple of minutes? Brilliant. Anyone got burning questions? I see your hand up. Hold on.
Many. Yeah, I'll be around after that talk.
Okay.
So yeah.
I don't know if these questions are relevant to others, so we can, of course, talk separately. By the way, the QR code was not working for us.
Not working.
And a lot of us here were trying to snatch it. So
Okay.
maybe you can.
So please, in that case, sorry for that. First of all, type creative AI Sony, and then you can reach.
Cool.
Yeah.
So, first of all, my apologies if what I'm about to ask you did just explain. So I caught about this much. Some of it was over here. Is the foundation model strictly in mathematical language and not the attributes that are training it? Are any of them available in natural language, or is it all mathematical language as far as the attributes that you're building off of?
Yeah, there are several types of attribution technologies, and one can actually does the thing you explained, like mathematically. You can go into the model and you see how the songs were generated, and then you can mathematically explain this song was used, this song was not used. But
in natural language,
natural language, I don't know. I think that's a separate topic. So natural language could be the interface of that. But
as far as how it's being trained, you don't put in attributes like feel or mood, and it's mathematical attributes.
Yeah. So from the attribution model, you can get some numbers. But it's also very interesting, written in natural language.
So that musicologists could follow along.
Yeah, exactly.
So
that's a great insight. Actually, the one we are developing, the music understanding model, can actually do that job.
Work in that. Okay.
Yeah.